very much for joining our webinar today. I'm Nikki, this is my colleague Vincent. We've had a huge amount of people join the webinar today, so we won't be able to answer your questions as we go along. If you put your questions to the Q&A, we'll answer those after the webinar. You can also email me at icky@vanwalt.com or call the office, and I'm happy to discuss your requirements, but please do send me an email. If you happen to be cut off during the webinar, please do stay on and we'll reconnect you. Over to you, Vincent.
Well, good morning and good afternoon, everyone. I know we've got some listeners from South Africa. Very welcome to you as well. I think we may have one or two from New Zealand. So this is a longish session, and you might ask yourself, why do we need such a long session to talk about samplers for what maybe seems to be a relatively straightforward activity? That's to take a soil sample. Well, the reason is that taking a soil sample has to be done correctly, because if you take an incorrect sample, your results will be incorrect, and therefore your conclusions and those data that you get from those samples will be incorrect. And the two things that we need to, or three things really, that we need to identify are the errors which can take place when you take sediment samples. And the first one is, of course, human error. You've got to make sure that you know where you have taken the sample, what is the location. So the correct description of the location is really, really important. The other thing is to make sure that you do not introduce any contaminant from your sampling equipment. That's a fairly cardinal sin. So this is where you've got dirty material and you are taking a sediment sample, and you find that you have in fact brought a contaminant to that particular sample. And the third thing that I want to make you all aware of is to make sure that you know from what horizon the sample comes from. So mixing horizons is always a really, really big issue. If you're sampling from 30 to 60 centimeters, it's important that you're sampling from 30 to 60 centimeters without having damaged the sample by bringing in sediment from, let's say, a higher level. So we're going to start first with some accessories which are common to all the devices that we are going to show you today. Just before that, I want to talk a little bit about the materials of equipment for soil sampling. What you will see here in the main are items which are made of metal. There are one or two exceptions which you will see later. They're made from metal, chromoly steel. One or two items are coated. They are coated because it makes them easier to clean. And quite a few of the items that you will see will be stainless steel 304. A little bit on maintenance, because it's a question we get asked a lot. How do we maintain and clean the equipment? Generally speaking, you clean with fresh water, particularly when you have been working on contaminated sites, or indeed in sites with where there's brackish water, for example, on the beach, and occasions like that. Rinse them with fresh water. We do not recommend that you add any lubricants to the devices. Now that's really, really important, because even if you get an inert lubricant, you may find that in its mixture it contains a compound which may be a compound that you are wanting to test for. So we do not recommend that you use any lubricants at all. So if you want to clean them, use fresh, clean water. Will they go rusty? Yes, they're made of metal, they'll go rusty. It doesn't matter. So you do not need to clean off the rust. The earth is full of iron, so the little bit of rust that you get on the samplers are really of no consequence at all to your samples. So this is expanding a little bit on the introduction here. Those are the few things that I wanted to mention about taking sediment samples. And we're also going to particularly look at devices which are capable of taking sediment samples in hard conditions, hard, dry soils, but also in those conditions, and generally it makes it a little bit more difficult where you're dealing in in sediments which are not cohesive at all, very sloppy, muds, for example, or even very wet material, wet peat, and so forth. So I'm going to start with talking about the accessories or the items which are common to most of the equipment which we are going to show you today. And I'm going to start with the connection type. And the connection type that we use is, we call it a hex quick pin. You may not see that very well on camera, but it's a hexagon. And the devices slot into each other like that. So all the forces when you're turning are not on threads, for example, which can get very, very difficult to undo. The connection is quite simple. You make the two pieces, and then there is a clip which goes into the device and locks into place, and now the item is ready for use. So that is the connection that we use. There are many, many connections in this world. We try to stay away from the threaded connections. Some threaded connections are okay, but mostly they will jam, and certainly if they're not immediately clean and you've forgotten to disconnect something, the rust will make them, they will rust together, and it'll be quite difficult to undo. So hex quick pin, very easy system to use, very robust, very, very strong, and that is our preferred connection. And I think all the equipment that you see today, bar 2, will have that same connection type. So I'm going to show you some more accessories, and let's talk about the handles. Now, this is a handle. Can I just show other types of handles? If you are taking the occasional soil sample, a standard handle is absolutely fine. If you're taking many samples, so repetitive samples, it is better to use a handle which is on a ratchet. So this is a ratchet handle. You can twist without actually damaging your body. So if you're taking a lot of samples, we would strongly recommend that you take a handle which makes your life a little bit easier. The other thing that we're looking at is the length of the handle. So different sampling devices are of different lengths, and we have handles of
10 centimeters, and this one is 1/2 meter length.
Yeah. And so they come in different lengths because it's always important to make sure that you use, when you're sampling, you use your devices from a correct height so that your body posture remains straight. You don't have to work above your height, and you don't have to bend over too much. So using the correct handle is important. And I'll show you a very special type of handle, maybe the drop tube, Rosie, if I might, the hammering hammer. Yeah. In some cases, can I have the hammer as well? In some cases, you may want to hammer on the auger, be it a gouge auger or something similar, and then there is another type of handle which is a heavy-duty hammering head, and we use a little mallet which goes together with that, which makes it easy to insert these things into the soil. Another accessory which is quite important in this in the sets that you will be seeing is the a hammering head.
Slide hammer.
Slide hammer. And again, on the one side, I'm trying to do this so I don't clonk you over the head with it. On the one side, you've got again the hex quick pin connection, and it's a really good tool because you can hammer down. But actually, you could use, when the item is inserted, you can actually pull up the auger by reversing the action. Incidentally, we have occasions where people are using these in extremely hard conditions, that some damage can occur to this section, and I don't know if you can see it here, but there's a little grub screw in place so that if ever this side is damaged, we can actually replace just the item which is broken.
Yeah, so you'd essentially just replace the studs, which are quite cheap, and you wouldn't need to replace the whole hammer.
Extension rods. So in the same vein as I was saying, use the tools to the correct height so that you don't strain your body. Extension rods are in a meter length, but they're also available in half meter. And we really would recommend that you use the correct lengths of extension so that you don't harm yourself. Incidentally, these are made of stainless steel, so very easy to clean, and also because they're standard lengths, 50 centimeters and a meter, it's very straightforward to determine to what depth you might be working. So if I can just pass those on, and maybe also the quick pin. Could I have the spatulas and the liner, please? So you've taken a sample. You also need to get it out of the device, and for that you have a spatula. There's all manner of spatulas, including something called the Idaho spoon, which I'd like to show you. I've never been able to get on with that, but people better than me use a device like this to empty the augers of the soils. We tend to prefer these very straightforward spatulas. They come in, I think, is it 3 sizes, Icky?
3 sizes, yeah.
Come in 3 sizes, depending on the width and dimensions of your sampling auger. Which one you would use? Cheap, easy to use, and saves your fingers. Finally, on the accessories. Sometimes you want to take a sample in a liner. You may want to take it in a liner to take back to the laboratory. In many cases, samples will be stored, will be maybe frozen or used at a later stage, and you want to capture the sample in a liner. This is a transparent PVC. They come in different lengths, they come in different diameters. And just a word on emptying these. The easiest way to retrieve the sample from the liner is to cut the liner horizontally, and the tool which is the most useful for this is something called Dremel. Now, that is certainly available in the United Kingdom. I'm sure it's available in South Africa, but you may want to check. We can put the Dremel tools on the descriptions after this webinar. But liners are very important, especially when you're talking about undisturbed samples. You can write on this so you know where it comes from, what the top is, what the bottom is.
I'll also cut in and say we don't just offer the plastic liners, we offer them in aluminium and stainless steel as well. So in various different diameters.
Yeah, and that's important because it may also the material may be dependent on what type of study you want to make. So, for example, if you're dating, transparent tube is probably not so useful. So yes, they come in different materials. In fact, you can get these in black material as well, where light influence is problematical. So those are the accessories, and I started with those because they are going to be common to a lot of the equipment that we show you, and we're going to take things progressively from the standard augers to more complex items which are made for very specific applications. So first onto the simple hand augers. There are many different types, and there are different types because you have to cope with different types of sediment. So in my right hand
is an open-faced auger, 64mm diameter, very good for clays.
Very good for clays, aren't they? Nice and open, so very easy to empty. Next one I want to show you is an auger for what we call stony soils. Let's see, how can I get the image? You can see, if I hold it like that, you can see that you've got these pointy bits, and the theory behind this is that if you hit a stone, you use one of these, and if you are lucky, these tips will push the stone aside so you can continue with your sampling. Not a tool that you want to use for general sampling, because it's actually quite difficult to empty and it disturbs the sample quite a lot. And incidentally, if I can have that one back, any of the hand augers, they take what we call semi-disturbed samples. So whereas you can certainly work as a profile, within that profile is relatively undisturbed, in fact pretty undisturbed. Why we call it semi-disturbed is, of course, you're twisting this, and in twisting you're actually mixing up the sample a little bit, which is why we call that semi-disturbed rather than undisturbed sampling, which you would do with tools which we will show you a little bit later on. Another type of auger head is
sand auger head.
Sand auger head, but also really good for hard, dry soils. Try not to use this as a standard, because it is more difficult to retrieve the sample, although we will show you a device later on which works in conjunction with this, which can make things a little bit easier from the sample retrieval. Incidentally, what I did forget to say is that most of what we show you today has got some standard sizes. There is no standard what size should you use. Mostly we use 75mm in diameter. In some cases we go a little bit...
70, so you've got 75, 70 and 50mm.
And 50mm.
But generally with the augers for the sand and the clays, they are standardised as 70mm diameter.
You can get bigger ones, of course. As they get bigger, they get progressively more difficult to use. So it's important to try and standardise on a diameter. And incidentally, and what a lot of people do, they take a combination of 70 or 75mm, but they may have some which are a little bit smaller, where you don't need such a big sample, and of course smaller augers make your work a little bit easier. Finally, something, a type of auger which is commonly referred to as a Dutch auger or Edelman auger. These are this shape here, really, really good for softish soils. And also very good for clays, for example. Easy to empty. Again, two sizes,
50 millimetre and 75.
50 millimetre, the small one in my left hand, and 75. I'm trying to get this so that you can actually see.
The total length is 60 centimetres for these.
Yeah. So you would attach a handle to that, of course, and
any extension rods.
And any extension rods. A question that gets asked a lot: how deep can I go with a hand auger? It depends how physically fit you are. You can go down to great depths, but we would say sort of 7 to 10 meters in loams is quite easy to achieve. If you're in heavy, dry, stony soils, maybe a bit less than that. But it is an important point, because we have a lot of questions from people who say, "Oh, we want to use a mechanized system for taking our samples," and we have mechanized systems, and they are very good, but in general they are relatively heavy. And it was delightful actually to see from the people who registered how much interest we've had from environmental consultancies, because over the last 10 years we've been dealing a lot with water sampling, surface water, subsurface water, and there's been relatively little attention given to taking soil samples, and it's great to see what a revival there is in the questions that we get on a daily basis. I think, Vicky.
Yeah, we do. I think historically a lot of the environmental consultancies subcontracted the soil sampling, but it's nice to be able to, I mean, they're using the augers themselves and doing the sediment sampling as well. So
finally, on the hand augers, we've shown you they come in two parts, which is the last items which we've seen, but they're actually also available in one length systems. In this case, a 50 millimeter Dutch auger, and in this case here in 75 mil. 75 mil. Total length, Vicky?
1.2 metres.
So 1.2 metres. I just want to point out here that the handle is actually disconnectable. Now, despite that, we call this a one-piece auger, and the reason we disconnect is that they're much easier to pack. So for shipping, it's a lot easier to use to disconnect the handle.
Yeah, and just to point out, this uses a completely different connection. It's not extendable. It really is a single piece, and that just comes apart for transport.
So, mind your head. So those are the accessories, hand augers, different types. There is one thing that I have forgotten to show you, because it's very small. In some cases where you are dealing with, where can I hold this so you can see it?
It's tiny.
It's tiny.
Just to point out, there are bigger core catchers.
There are bigger core catchers. This, if I can show you, is a core catcher. There will be occasions where you're trying to capture a sample, but the sample is so sloppy, there's no cohesion to it. The sample will just fall out of your sampling device. Not just because it's sloppy, but because there is no friction to retain it within the sampling device, and you would use something called a core catcher. And I'm sorry, I can't show you anything bigger than this. As Eki said, they're available in all manner of diameters. What is important about this is that good practice is actually never to use a core catcher unless you have to. And the reason you don't use a core catcher is that the sample is a little bit deformed as it passes the core catcher. So the principle is that the sample goes through the core catcher, but it can't fall back out again. But it will score your sample and it will deform it a little bit. So it's really a last resort where you're losing all the sample. Just make sure that you use a core catcher, but as a matter of course, don't use them. How are we doing for time?
I think we're okay. I think we're on the sediment grabs next.
So now we get onto the more exciting stuff, and that is to take samples below the water level, and this becomes a lot trickier. You cannot do that with a standard hand auger. Even if you were to reach the sediment, generally the sediment will be, by definition, wet. It's underwater, and mostly it is very sloppy, and it'll just fall out of the system. And therefore, we need to look at other devices to allow you to take good samples. And the first one that I want to show you is something called a Van Veen grab. Now, this is a device which is lowered from a bridge, from a boat, to the base of your, how do I do this so that I can show it? So lowered to the base of your pond or river or lake. And what happens with this tool is that it's deployed in an open position, and it's lowered on a string, on a rope, down to the lake bed. As it comes to the base, automatically the jaws are triggered, and I'm trying to not take the table with me. The jaws close and the sample is contained within the sampler itself. This takes about...
It's a 2.8 litre capacity.
2.8 litres, so it's a very small one. They're available in all different sizes, and I'm just going to put this little...
This is a standard and the most popular size. They get quite heavy after that. I think after this size it goes up to about 6 litres and a little bit beyond.
It gets pretty heavy, I think. This one is already 8 kilos. And it needs to be heavy, and this is important when you use this device. Make sure that it's heavy enough to do the job that you want to do, because if it's too light when you hit the seabed, it's not heavy enough to penetrate into the soil, and therefore when the jaws close, it's not taking any sample at all. So yes, it has to be a little bit heavy. This particular one is a good mixture of enough weight to do the job. Of course, you only get the surface material. So excellent for seabeds, riverbeds, even large tanks, for example, where you may have sediment at the base of the tank. You need to collect that, and you would use something like the Van Veen grab. Next on the line is a device which is called a bomb sampler. Now, I know we're talking about sediments, but actually this is both a sediment sampler and a water sampler. And what is it? I'm just going to disconnect this bottom rod. It's a stainless steel tube. It's more or less empty inside, but I'll show you what it looks like inside in a moment. At the top you have 2 harnesses, an outer one and you have an inner one. And if I pull on the inner one, you will see that there is a plunger there which is lifted. At that moment in time, the base of the sampler is open, so the water will go into the sampler. Usually we say allow up to 10 seconds to do that. And once you've done that, you release, and now the sampler is actually locked in position with a sample inside here. It's about just over half a litre, 600 millilitres, I think. So whereas it's useful to take water samples, and our colleagues in South Africa, you have very, very deep wells, for example, and you may want to take a water sample at a discrete level. So let's say at 125 meters. You could use a device like this to take your water sample from that particular horizon in the well. So that's a possibility. The other thing it's very good at is to take the important levels in a contaminated seabed, for example. Let's say that you have a harbour bed which is contaminated with anti-fouling chemicals. You may be interested not just in the water, in the seawater, but you may be interested in having that water which is really, really close to the seabed. And for that, I've disconnected this bit here. If I reconnect that, you can lower this from a boat or from a bridge, for example, and you drop this until you hit the seabed, and automatically, as you hit, that valve will open. So what you're getting here, you're avoiding to get the actual sediment inside, but you're getting the layer immediately above that seabed, and it's an important layer because this is where you may be particularly interested in when you're doing studies such as anti-fouling residues in harbours, or indeed you may want to measure water in lakes to see what is close to the sediment at the base of that particular lake. I'll just open the device so that you can see what it looks like inside, and it's important that that this is done also to clean it. Bottom part just unscrews. The top part similarly unscrews. And that's how it's constructed. And the reason I'm showing you it's not interesting from a technical or an engineering point of view. It's that when you have used a sample, you have got to clean it and decontaminate it because essentially it's a water sampler. So just take it apart, wash it, decontaminate it, and put it back together again. So that's the bomb sampler, called like that because it looks like a bomb, I guess. But it's a really useful device.
We might need to rename it.
We may need to rename it. Really useful device also for tanks or